This video is on a concept which is called expected frequency, and I'm going to do some examples which are related to this topic. So first of all, we need to understand the meaning and the applications of expected frequency in maths. So expected frequency is simply equal to the number of times the experiment is done times probability of the event happening. Because basically you can estimate the number of times an event will happen by working out its expected frequency. So it's basically the frequency or the number of times that we expect that an event will happen. But this is like an estimation. That doesn't necessarily mean that it's going to be 100% accurate. For example, let's say that when we roll a six-sided fair dice, the probability that we get 6 is obviously 1 over 6. Now let's say that we want to roll a dice for 100 times. So our frequency or our n is 100 because we want to roll the dice 100 times. Now the question is, how many times do you expect out of 100 times that you are going to do that? You're going to get number 6 when you roll a dice. So in that case, the question is simply asking us the expected frequency. And if we want to work out the expected frequency, that just can be found by simply doing the total number of times the experiment is done, which is 100 in this case, times the probability of the event happening. And in this case, because we said getting 6, so getting 6 in a dice is 1 over 6 because that's a fair six-sided dice. And the expected frequency in this case is going to be 100 over 6. So this is not a whole number, obviously, but that's not the purpose of this video. I'm just trying to show you basically the applications of expected frequency. And now I'm going to do 3 examples from this topic. So hopefully by the end of the video, you will have a better understanding of this concept. And so let's get started. Okay, so let's start by doing the first question, which says that the probability that a biased dice lands on 4 is 0.75. Okay, so we have a biased dice. It's not fair, so that means that all the events are not all the outcomes are not equally likely. So for example, getting 4, maybe the probability of getting 4 is more than the probability of getting 2. So that's the meaning of bias in probability. So yeah, the probability of getting 4 is 0.75. And the question is, how many times would you expect to roll 4 in a 20 rolls? Okay, so it's simply giving us the, in each part, is giving us the total number of times that we do the experiment. And for example, in part A, we do the experiment for 20 times. And now we want to see that how many out of 20 times are we going to get 4 when we roll that dice. And we said that expected frequency is equal to number of times the experiment is done times the probability of the event happening. So it's going to be 20 times 0.75. And now we can just work out that, which is going to be 15. So our expected frequency is 15, which means that when we roll this dice for 20 times, we expect to get 4 for 15 times. That's basically the meaning of that. Okay, so now let's do part B. So all the other parts of this question are going to be the same. So in B, it says that when we roll this dice 60 times, so the probability, sorry, the expected frequency is simply going to be 60 times 0.75. And this time that gives me 45. So when we roll this dice for 60 times, we expect to get 45 times. So 45 times out of 60 times. Okay, this time, what if we roll that for 100 times? So that's simply going to be 100 times 0.75, which gives me 75. So we expect to get 470 times. And finally, how about doing that for 1,000 times? So it's going to be 1,000 times 0.75, which obviously gives me 750 times. Okay, so that's it for for question A. Now let's do the next one. Right. Now, in the second question, we have a spinner on the right which has 3 equal sections. So I'm going to highlight here because this is important. And then it says that how many times would you expect to spin penguin in a 60 spins? Okay, so first of all, in the first sentence, it says that it has 3 equal sections, which means that the probability of getting each of these, I mean, getting 1 or 2 or penguin is 1/3. That's because the probability is equal to 1/3. That's because they're all equal sections, so they have the same probability because they're all equal. It's like a fair spinner, if you like. And here is also 1/3. Okay, and then it says that how many times would you expect to spin penguin in 60 spins? Right, so in this question, they have kind of hinted that it's going to be to do with expected frequency, because they have said that how many times would you expect. So expect and how many times are our keywords in this question. And yes, so again, expected frequency is equal to the number of times that the experiment is done. In this case, part A, 60 spins or 60 times, and then times the probability of the event happening. So the probability that this event happening or getting a penguin is simply 1/3. So that's just going to be 20. And that's it for part A. So we expect to get penguin 20 times if we have 60 spins in total. Part B, so the same thing with just different numbers. What if we have 300 spins? So it's going to be 300 times 1/3, which it gives me 100. And finally C, which says that 480 spins. So this times 1/3, and that gives me 160 times. Okay, that's it for this question. And finally, the last question. A first 6-sided dice is rolled 120 times. Again, this is like the total number of times that the experiment is done, or the frequency. How many times would you expect to roll a 5? Okay, so again, the expected frequency is equal to number of times the experiment is done in part A. In this question, we basically have done that for 120 times the probability of the event happening. So here we should be careful because this question is a bit different to the ones we did. So because we know the number of total times, but we need to know the probability, because we need to work out the probability by ourselves, and then we can work out the expected frequency. So in the first part, because it says that it's a first six-sided dice, which means that the probability of each outcome happening, they are all equal. So they're all equally likely, which means that the probability of getting 5 or 6 or 1 or 2 3 or 4 is just all 1 over 6. So the probability of getting a 5 in a first six-sided dice is obviously 1 over 6. And since now we have worked out our probabilities, so we now need to plug that in the formula, which is the formula for the expected frequency. And our expected frequency can be worked out by doing this. And that gives me 20. So I expect to get 5 for 20 times when I roll that dice for 120 times. Now I'm going to do part B, which is exactly the same as A, because okay, so the probability of getting 6 is simply 1 over 6, again, because that's a first six-sided dice, and the expected frequency is equal to 120 times 1 over 6, which gives me 20 again. So the interesting thing here is that we expect to get 6 for 20 times as well, so which is completely fine. I mean, don't think that it's not possible. It is possible, yeah, because also for getting 5, our expected frequency was 20, and that's the same with 6. So for both we expect to get 20 times. Now part C, it says that getting an even number. So we should read the question carefully. So in a dice, there are 3 even numbers, which means that the probability of getting an even number is 3 over 6, simply, in a dice, in a first six-sided dice. Now, working out the expected frequency of that, that's going to be 120 times 3 over 6, and that gives me 60. So that's our expected frequency of getting an even number. And finally part D, which says that getting higher than 1. So we have 5 possible outcomes, right? Because that just means that the probability of getting 2 or 3 or 4 or 5 or 6, which is going to be 5 over 6. And again, we are now going to plug that in to the formula, which is going to be 120 times 5 over 6, and that gives me the expected frequency, which is 100. So that's basically how we can do questions like this, which are all about expected frequencies. So I hope this video was helpful to you, and please like and subscribe for more videos.